Section 1.4, measurements. So we've got one more way to break down different types of properties. Here we are looking at quantitative properties versus qualitative properties. So I talked about this a little bit earlier in the unit, or in the chapter, when I was talking about observations. So quantitative properties are properties that are measured and expressed with a number, and they include a unit. So for example, length. Qualitative properties, they do not require measurement, and they are just based on sensory observation. So for example, color, right? I could just look at a piece of paper and tell what color that it is. This is a qualitative observation. Now in this course, we're going to be looking at English and metric units. Now we are primarily going to be using metric units. So some common English units, or they're sometimes called imperial units that we use here in the United States, are foot, gallon, pound. Now these conversions, they are pretty antiquated. They use hard to remember numbers. So for example, there's 1,760 yards in a mile, or 5,280 feet in a mile. There's 4 quarts in a gallon. There's 12 inches in a foot. So these are a little strange, and if you're given a problem with some English or what are called imperial units, you are going to be given the necessary conversions. Whereas with the metric system, much easier. So some common metric units are meters, liters, and kilograms. Now with the metric system, everything is related by powers of 10. So it is very easy to convert between units. For example, there are 1,000 meters in a kilometer, or there's 1,000 milliliters in a liter. Now here are the common SI or metric units that we'll be seeing in this course. So length is typically going to be in meters, mass could be in grams or kilograms, time in seconds, temperature will commonly be in Kelvin, but occasionally in Celsius as well. Now this is not something we'll use in this course. Electric current is amperes or A, and luminous intensity is candela or CD. So we won't see those two units in this course, but these are the official SI units. And the amount of a substance is a mole, but I'll typically abbreviate it as MOL for mole. Now these are some other common base units. Now these are not necessarily SI official. So length is still going to be in meters. Oftentimes masses, we'll be using masses in grams, though we could use milli or kilograms. And volume is technically not an official SI unit, but we will typically see volumes in liters or sometimes in milliliters as well. Now here are all of the SI unit prefixes you will need to know in this course. Now these will be on the reference sheet, so I'm not going to expect you to memorize these, though it is helpful to know the more common ones quickly off the top of your head to save you time. You just need to know how to use these prefixes to convert between units. So these are all of the ones that you need, going from pico, which is 10 to the negative 12th, up to tera, which is 10 to the 12th. Now, when we are going to start changing units. So when you change units, one of the ways to do this is to use conversion factors. So a conversion factor is a mathematical statement where you've got two different units expressing the same number. So for example, if I said 1 foot equals 12 inches. So 1 foot equals 12 inches, right? So mathematically, 1 foot and 12 inches, they are the same exact thing as one another. So because they represent the same value, just in different units, we can say that they are equal to one another. And since they are equal to one another, we can write them either way. We can write 1 foot over 12 inches, or we can write 12 inches over 1 foot. Because they are mathematically equal to one another, I can put either number and unit on the top or the bottom. And this is helpful because we can set up our problems in such a way that the units will cancel out. If I'm trying to convert from inches to feet, I would set it up this way. So that way, what I am trying to cancel or go away from goes on the bottom, and what I am solving for goes on top. If I'm trying to go from feet to inches, I would set it up this way. So for example, if I measure something and I find that it measures 3 feet and I want to know how many inches that is, well, I think we can all do that math quickly in our head. But just as an exercise to illustrate how you should use these conversion factors, I've got 3 feet. I'm trying to go away from feet and towards inches. So I would use this conversion factor right here with inches on top and feet on the bottom. So that way, feet cancels, and I'm left with the unit of inches. And so I get 36 inches. If I'm trying to go the other way from 24 inches to feet, again, we can all do that quickly in our head, but just to illustrate what I'm talking about here, the unit I'm trying to get rid of the unit inches, so I should use this version of the conversion factor that has inches on the bottom. So that way, inches cancels, and the only unit left on top there is feet. So I'm left with the answer of 2 feet. Now, when we're doing this with the metric system, changing orders of magnitude, the easiest way to do this, in my opinion, is to write an equality. So use an equality. So 1 times the prefix unit equals the power of 10 times the base unit. So for example, let's say you are trying to convert from milliliters to liters. So liters, it doesn't have a prefix, so it's our base unit. And milliliters, it has a prefix, so that is our prefix unit. So I would say 1 times the prefix unit, so 1 milliliter equals the power of 10. So you would find the power of 10 for milli. And milli, let me go back to the previous slide here. Milli is 10 to the negative third. So when I write this out, it's 1 milliliter equals 10 to the negative third liters. So here is our conversion factor. 1 milliliter equals 10 to the negative third liters. And so since these things are equal to one another, I can write it with the milliliters on top, or I can write it with the milliliters on the bottom. I can use either one, and I just want to set it up so the units cancel out. What I am solving for should go on top. What I am trying to eliminate, what I am going away from, should go on the bottom. So here, if I'm trying to convert from milliliters to liters, I would set it up like this, 26.7 milliliters. I want the unit of milli to cancel, so I would use this conversion factor right here. I would write 1 milliliter on the bottom and 10 to the negative third liters on top. Now I've got milliliters on top, milliliters on the bottom, so milliliters cancels, and this leaves just liters as my remaining unit. So my answer would be 0.0267 liters. Now let's say I'm doing a calculation with 2 prefix units. Let's say I'm trying to convert from 0.4 centimeters to kilometers or kilometers. So a strategy here would be to first convert the prefix unit to the base unit, then convert the base unit to the second prefix unit. So I'm going to convert from centimeters to meters, then convert from meters to kilometers. So here are my 2 conversion factors. 1 centimeter equals 10 to the negative second meters, and 1 kilometer equals 10 to the third meters. So now I'll convert from centimeters to meters like this. And then I'll chain this together and convert from meters to kilometers or kilometers like this. So you see, I put the centimeters on the bottom here because I wanted centimeters to cancel. And then I put meters on the bottom here because I wanted the meters to cancel, which leaves kilometers or kilometers as my final unit. So 0.4 times 10 to the second times 10 to the negative third. And I just took this and moved it to the numerator. So when you move something from the denominator to the numerator or vice versa, you change the sign of the exponent. So 0.4 times 10 to the negative second times 10 to the negative third gives 0.4 times 10 to the negative fifth, or this can also be written as 4 times 10 to the negative sixth. So 0.4 centimeters equals 4 times 10 to the negative sixth kilometers. All right, here's a knowledge check question. How many nanometers are in 3.45 times 10 to the negative first micrometers? All right, the correct answer here is C, 345. So let me briefly explain how you would do this problem. So we've got 3.45 times, 3.45 times 10 to the negative first micrometers. So I want to first convert from micrometers to meters, and then from meters to nanometers. So I need to write some conversion factors. So 1 micrometer equals 10 to the negative 6 meters. And then I'll also say 1 nanometer equals 10 to the negative ninth meters. So these are my conversion factors. So I've got 3.45 times 10 to the negative first micrometers. And I'm sorry, I know my handwriting is not very good. And I'm going to change some conversions together. So first, I want to convert from micrometers to meters. So I'm going to write 1 micrometer on the bottom, so units of micrometers cancel, and I'll write 10 to the negative 6 meters up top. Now I'm going to convert from meters to nanometers. So I'm going to use that bottom conversion factor, and I'm going to write meters on the bottom because I want meters to cancel. So 10 times 10 to the negative ninth meters on the bottom, and 1 nanometer up top. So now meters cancels, the only unit I'm left with is nanometers, and that's the answer that I was looking for. So this is an indication that I set my problem up correctly. So if you type this into your calculator, you should find the answer to be 345 nanometers. All right, now let's briefly talk about volume. So volume, as I mentioned earlier, is technically not an official SI unit, and this is because volume is a derived unit. Volume essentially is just a function of length, right? It is length cubed. So 1 meter cubed looks like this. 1 decimeter cubed would look like this. 1 centimeter cubed would look like this. So the official derived unit is a meter cubed, but the unofficial unit is a liter. All right, and so a 1 liter is actually equal to 1 decimeter cubed. One other useful conversion is that 1 centimeter cubed equals 1 milliliter. So you're going to want to keep this in mind, that a centimeter cubed and a milliliter are in fact the same thing. So when you're converting density values, this value or this conversion right here is useful. So let's briefly talk about density. So you also notice that density was not on that sheet, and that is because density is also technically a derived unit, or really it is a ratio. So density is the ratio of mass to volume. So to solve for density, it is equal to the mass of that matter divided by the volume. So D equals M divided by V. So the official derived unit is kilogram over meters cubed because these are the official SI units. But the unofficial units, we'll be looking at 3 different units in this course. If we're dealing with the solid, we're going to be looking at grams per centimeter cubed. Liquids are commonly given as gram per milliliter, and then gases are commonly given as grams per liter. So all 3 of these are possible, though the top 2 are going to be more common in this course. Let's briefly look at a density example. Suppose I asked, what is the volume that is occupied by an object having a density of 1.78 grams per centimeter cubed and a mass of 1.25 kilograms? All right, well, first you want to keep in mind that density equals mass divided by volume. Then you want to see, well, what is the problem asking for? And the problem is asking for the volume. It says, what is the volume? So V is the unknown here. What information has been given? Well, it states that the density is 1.78 grams per centimeter cubed. It states the mass is 1.25 kilograms. So you should notice here that we've got an issue. The units are different, right? My density is in grams, my mass is in kilograms. So I should probably convert this mass to grams before I proceed with the problem. What I also recommend you do is you rearrange. So I like to rearrange my equations first to isolate the variable I'm solving for before I plug the numbers in. So we are solving for the volume here, so I would multiply the volume and move it from the right to the left. So I would have D times V equals M, and then divide that density back to the other side to isolate V. So I get V volume equals mass divided by density. Next, again, you want to make sure that the units are the same. So you would either need to change the density from grams per centimeters cubed to kilograms per centimeters cubed, or you could change the kilograms into grams. I think the second option is easier. So I'm going to convert that mass from kilograms to grams using this conversion factor. So 1.25 kilograms equals 1,250 grams. Now I can plug my numbers in. So I plug the mass in, 1,250 grams, and I plug the density in, 1.78 grams per centimeters cubed. And my answer is 702 centimeters cubed. So this object occupies 702 centimeters cubed. All right, let's try a knowledge check problem. What is the density of an object having a volume of 253 milliliters and a mass of 91.6 grams? Okay, the correct answer here is A, 0.362 grams per milliliter. So in this problem, you just needed to solve for the density. So you would just divide 91.6 grams by 253 milliliters to come up with the answer. All right, that is the end of section 1.4. I'll see you in the next video for section 1.5, measurement uncertainty, accuracy, and precision.